have the number of electrons, the protons in the nucleus. This newly charged up atom, ion is its name.
Welcome back. In the last video we talked about some separation techniques we can use to separate different compounds and elements and mixtures. While I'm doing this video I'll cover two dot points because they're quite related, and I'll cover the first one first. The first one says assess the separation techniques for their suitability in separating examples of earth materials, identifying the difference in properties that enable these separations. So what does assess mean? Assess means we just have to be able to think of can we use a certain separation technique to differentiate between certain compounds, and if we can, why can we do it? So these are the answers we have to be able to give, and then we have to also identify the difference of properties, and I'll go over that as well in a second. So for example, again, this is a quick example to hone back down on what I actually was talking about. So if we have, for example, we've got fancy rocks and we've got these plain rocks, and we want to be able to separate these. So we have them all together, mixed together in a mixture. We want to separate them from each other. Can we use a sieve? Would this be a suitable separation technique to be able to separate fancy rocks from plain rocks? And obviously the answer in this case would be no, it wouldn't be suitable. So we said can we, and that would be a no. And why? Well, we can't, because they're both property-wise, their properties are they have the same size. There's no difference really in the size, so they're not going to actually be sieved out by this small sieve, which means we can't separate them using this sieve. So that's what that is all about. We have to think about, can we use a certain separation technique, and if we can, we have to give reasons why as well. And we have to relate that back to the properties. So for example, we've got our separation techniques which we explored in the last video, a couple of them. And here are a couple of things we want to separate. So for example, let's say we want to separate gold from sand. That's quite common. A lot of people look for gold and then they use those sieves to be able to actually do that. So I just gave the actual answer. What will we use? We could use this sieve. And what property will we use? The property of that the gold coins, so not the gold coins, but the gold stones, are larger than the sand grains. So the sand would go through the sieve, and only thing that's left over is gold. So sieving is the appropriate technique because of the property that gold is bigger in structure than sand, and sand particles would be sieved out. Left over would be gold. If we have kerosene, and we want to separate kerosene from water, what separation technique will we use? Well, we should know kerosene is a type of oil, so that is an immiscible liquid, it doesn't mix with water. So in this case, we would be able to use a separating funnel, because this deals with immiscible liquids. Remember, that was the actual funnel that we could just separate two liquids that couldn't mix by opening the tap and waiting for the one liquid to leave, and then the leftover liquid is, in this case, oil, because they just don't mix. So we used a separating funnel for this, and the property was that they were immiscible. That was the property that allowed us to use that. So we used a separating funnel for that one. Okay, this is a bit of a weird example, but let's say we have worms, and the worms are in sugar solution. So what could we use to separate worms from sugar solution? Well, we could use, for example, filtration. Remember, filtration was all of a filter paper and a filter funnel, and we use that to separate solids from liquids. And even though this sugar is actually a solid, but it's soluble, so it's dissolved in the actual water. So we can use that. We can use filtration to get rid of the worms. They will be left over. And the filtrate, which is the liquid, will be our sugar solution. So we can use filtration for that. Now the next one is if we want to separate salt, which is a soluble solid, from water. So maybe in salt water, we have salt water. We want to separate salt from water. What we could use is we could use something called evaporation. And the property you would use, the reasons why we could use that, would be to do with the fact that they have different boiling points. So the property would be boiling points, because salt has a really high boiling point of a couple hundred degrees, whereas water only has 100 degrees. So if we get the salt water into 100 degrees, we would evaporate all of the water, that be gone, and we only have salt left over. So we could use evaporation for that. Now if we have bromine and we have water, and bromine water, and we want to separate those, the problem is bromine is actually a miscible liquid. In this case, it mixes with water. But the other one was the immiscible, kerosene and water, so what could we use? Well, we could use distillation. And what you should also know is just the boiling points. The boiling points of bromine is about 59 degrees Celsius, whereas 100 degrees is for water. If you remember how distillation worked, distillation was built different boiling points. The property we use for distillation is also different boiling points. And the reason why is if we have that distillation flask, we can bring it up to a high temperature, which gets rid of the bromine, because the bromine has, so for example, if we say we have it at 65 degrees Celsius, then all the bromine water will have left and condensate out in a different beaker, whereas the water is left over. So that's how we can use that for this separating bromine from water. Now the actual dot point says we should cover some earth materials as well. And these are going to be two new ways of separating substances. For example, if we have minerals and we want to get that away from our gangue. Gangue is just a waste. Like if minerals are like stuff like zinc and copper, stuff we want, and you can mention that gangue is just to be like the waste product. So what we could actually use, we could use something called Froth flotation, which is this here. And how this works is you actually have, you put in both your minerals and your gangue, which are together in a mixture, you put them in, and this here has a higher wettability. We call it wettability, which means that the property is that more water sticks to our mineral. And what that means is that gangue will drop down, so you can see the gangue is here, it is dropped down, and that froth wets the actual mineral, and the froth will actually float up and be on top. What we can do then, we can just skim the froth, and the froth is all our mineral. So that's how we can separate useful minerals from waste, using froth flotation. Another way we can separate earth materials, for example iron from rock, is something called magnetic separation. This is what this is here. So what you can imagine here, we have a device which has both iron and rock together. And what's going to happen is iron is magnetic, and it's going to go past, but then get stuck on this magnetic wheel. So you can see here, these are all the iron casings. And rock doesn't, because rock's not magnetic, rock will just leave and get shot out. So the property that we use to separate iron from rock can be magnetism. Iron is magnetic, whereas rock is not. Right, so that was the first dot point, and I'm going to quickly go over the next one as well. And this was just using so they identify data sources, choose equipment, and perform a first investigation to separate the components of naturally occurring or appropriate mixtures, such as sand, salt, and water. So we just mentioned a couple of things we can use to separate different substances, and now we need to separate sand, salt, and water from each other. So here are some of the facts you should know. Sand is insoluble in water, and salt water. So sand is insoluble, salt is soluble in water, and the sand particles are too large to fit through filter paper. So we want to separate salt, water, and sand from each other, and how do we do that? So what you would have had in class is something similar to this. You would have had a beaker, stirring material or a stirring rod, filter funnel and paper, drying oven or electrical hot plate, sand, and salt water solution. Your first step would have been to put in the sand. So these brown dots are supposed to be sand. Put the sand into your salt water solution. So now we have sand, salt, and water all together. So we have all of it together. Now we have to obviously start actually separating them. The second step is we want to separate the sand. And how can we do that? Well, we can use a filter paper and the filter funnel, because we said that sand particles are too large to fit for the filter paper, but the salt solution is not. So if you pour this in, what will happen is you have our actual water, which will accumulate, salt solution accumulate on the bottom, because it's just passed through, whereas our actual sand will get stuck in the filter paper. So now here we have separated sand from salt solution. So sand from salt solution. And we used filtration to do that. So filtration was a mechanism, the process of doing that. So, and the process was filtration. And the reason why, so the property we used was the fact that the sand particles are too large. They won't fit through, whereas the salt solution will have no problem. Next, what we do is we do something called evaporation, because we're going to put that salt solution beaker onto electrical hot plate. And this is a heating source. This is going to heat things. So now our water, which is now salt solution, will leave. It will evaporate. And what's going to be left over? What's going to be left over is generally just your salt. So this will be salt. Obviously not that much, because most of it's going to would have been water, but you will have salt left over because of evaporation. So we separated salt from water through evaporation. That was the name of the technique. And the reason why, again, the property was boiling point. So this is what you're going to do in class eventually, or something similar to this. So the dot point was all about looking at suitability. It says the suitability, like why would we use certain techniques to separate certain substances, and we have relate that back to properties. So what properties would we actually use to do that? And the experiment would have been very similar, just to show you the hands-on kind of thing of you doing it with sand, water, and salt. I hope this was useful.
Thank you for watching.